The biggest misconception about local AI right now is that the goal is running frontier AI models on your own hardware just to avoid API costs. But that's not the interesting part. The real advantage is using small focused models on cheap hardware you already own. Full privacy, complete data independence, and zero vendor access. I'll show you a couple of apps I built this way so you can do the same. Welcome to Made by Agents, my name is Tobias, and let's get started. The real advantage of local AI is not what you think. There are two very different ideas of local AI, and there's one group that, in my opinion, is the misconception, and this is about running the newest, biggest, most intelligent frontier AI models on your own hardware, or at least trying to do so, with the goal to save on API costs or monthly subscriptions, maybe also for privacy reasons. But the problem is that it's almost impossible to keep up with the cloud providers and solutions and with the newest models that get bigger and bigger and bigger and more memory hungry. At the same time, we saw a price inflation in memory over the last months. On my website, madebyagents.com, I built a couple of tools to help you research what runs on your hardware or what hardware you actually need to run different AI models. And I also built a couple of calculators, for instance, a return on investment calculator, where you can compare the local AI cost versus cloud API pricing to see when is it worth running something locally and when does it actually pay off. I also have a self-host versus rent versus API calculator here. And when you open this up, you can select a hardware device and an API model to compare those together. When you want to run frontier AI models, right now, at the time of this video, you could run something like Kimi K3. And when you go to Hugging Face, where most of these open weights are hosted, and you look at Kimi K3, maybe this GGUF format from Unsloth, you want to run this in 4-bit quantization, you need 1.51 terabytes of VRAM just for loading the weights without even KV cache and the context window and so on. The 1-bit really lowest quality version still needs around about 600 gigabytes of RAM. Now you can do the math, what hardware you would need to run this. Let's say this will cost you $15,000 or maybe $20,000 to purchase and has a power draw of 1,000 watts. And let's say you're a power user and really consuming a lot of tokens, so you're using this device, that means it will cost you more in electricity. And you live somewhere where you pay 30 cents per kilowatt hour. And let's say your time horizon is 48 months, because after that you need to upgrade your device again. It's getting outdated. And let's say you're paying 200, or you're comparing that to a subscription of $200 a month. And let's say you have another subscription for $100, so you're paying $300 a month right now. And then click on calculate. And you can see that within the time horizon, you're not able to reach return of investment. So it means the cloud API, the $300 a month, is still more cost effective for your usage pattern, because it just takes a very long time to pay off the cost for the hardware. And at the same time, your hardware probably devalues because it's getting older, and on the used market, you will get less and less for it year after year. Another idea, which I find is the idea to go with, is running very small and focused models. For example, a 3 billion parameter model, which runs on almost every consumer hardware with similar goals in mind to reach full privacy and data independence. No external provider ever sees a single of your tokens. Let's look at where your data actually goes. And when I'm architecting a new application or a system, I always think about where to deploy AI models. There are different levels to it, and it's not always possible to deploy everything locally, or it's not always making sense. And sometimes for some parts, it's all right to deploy it on a rented GPU or use a privacy-oriented API or just the mainstream API. Obviously, the most private level is running everything locally on your own hardware, open source models that you download, so nothing ever leaves the machine. And you can achieve that with using an AI inference engine like Llama, C++, Ollama, or something else. The slightly less private option is running open source models on hardware that you manage yourself, for example, a company server. Then you can also deploy models on rented GPUs, for instance, on Runport, Vast, or Amazon Web Services. And when you check out Runport, for instance, you can see that you can run K3 now on this service. So a 2.8 trillion parameter model. And this only costs you a few cents or dollars per hour. So depending on your usage, you're only paying for the time that you're actually using the GPU. Another option is using private AI APIs, for example, Tinfoil or Maple, and they encrypt the data that goes to the server and back, provide you with more privacy. You can check it out here. Tinfoil, for example. The downside is they only support open source models, but this gives you more privacy. Least private option is using mainstream APIs like Anthropic, OpenAI, or OpenRouter. The thing about local AI is that it doesn't need to be as smart as frontier AI. It just needs to be reliable, private, and always available. And the formula is really simple. You use a small focused model, which does one job really well, and you use the hardware you already own, a laptop or an old Android phone, and you reach the same privacy and independence. You can run it offline, you have no rate limits, and your data stays on your machines. There are a lot of different apps you can build with this, and I'm going to show you a few examples. One type of app is a CRM that you could build, and you can use local AI, for example, to import and enrich contexts automatically. This makes sense whenever you need to protect your customer data and you want that it stays on your machine or on the servers that you manage. You can also build ERP systems that you can control with voice or text commands and manage orders, inventory, production data. But you can also build something as simple as a meeting recorder which transcribes and summarizes your conversations locally without using any third party. I prototyped a natural language to SQL application that I'm gonna show you now. And here are a couple of things it features. Here we go. This is how it looks like. And for the AI inference engine, I use Ollama for this. If you don't know this yet, you can check this out here. It is, I think, one of the easiest ways to spin up a local server for your open source models. And you can install this just by running this command here or download the app for your operating system. As soon as you have this installed, you can search for the right model. And this is obviously a topic for itself. You can also find a lot of information on my website, which AI models you should run, could run for your hardware. I have a model directory with a wizard which guides you. Let's say you want something that's good at coding and runs on very little RAM and provides the fastest speed. And then it provides a few model options here for you. And then you can look into this in more detail with all the different specs. Otherwise, you can also check out hardware. I have a hardware calculator, and here you can select your hardware device. Let's say you have a Mac Mini M4 Pro and you want to run text models here that are in the range of maybe 3 to 7 billion parameters. And you click on calculate, and then you see here a table of different model options that you could deploy and how fast this will run approximately based on the memory bandwidth of your device and a rating system, the context window, and so on. And then you can get the details here and also the direct links to Hugging Face and Ollama. In this example here, I just looked at a very small Quen model, and I'm gonna install this smallest 0.8 billion parameter Quen 3.5, and this only needs 1 gigabyte of RAM to load the weights, but still provides 256 context window. I don't even need so much for this application. And when you run this on Apple Silicon, you can go for this MLX version of the model. This is optimized for Apple Silicon and will run even faster. So I copy this now, and you can run this command, Ollama run, and then the exact ID of this model type. And then it will automatically download it and start a conversation with this model. Another way is to open up the Ollama UI as soon as you have this installed. And this looks like this here. And here you can also chat with the models you have downloaded. You can see it here in the list. And now when you paste this model ID, you will find this here, and you can click on this download icon, and then it will also download the model for you. Let's select this here now, and now we can just send a test message to see if this is responding and working. And you see it's working. So for this example here, natural language to SQL, we need a model that supports tool calling, and then ideally a model that's really good at writing SQL code. So the model I just picked is not the best. I think there are better options, models that are really better at coding and so on. And I could also go slightly higher here with the gigabyte requirements. But just to show you like how well this works, even with a tiny model that runs on old Android phones, or I mean on almost every device, let's keep this model for now. Another thing that is important now to get this working is to open up the settings of Ollama and to enable this option here, expose Ollama to the network. This is key, otherwise your app can't find or connect to the local server. And now we can start querying our databases just by natural language commands. And let's say we are interested in the inventory below reorder level, and now we get the table here. We can toggle this SQL button, and we can see the raw SQL code that the model wrote for us. And here we can also make modifications if we want and run this again. And now this is limited to only 10 items. And when we click here on chart, this is visualized now in different formats. And here we can also download this as an image file. And let's say now I want to have all orders by status. And now we see what's shipped, what's processing, pending, and so on. So I think that's a pretty cool use case for local AI. And when I click here on browse data, I can just look at all the different tables to see what we actually have come up with new prompts. For example, all machines that are running. And now this gives me all the machines that are currently running. And if you want to build something similar, this is how the stack usually looks like. So you need an AI inference engine. In this case, I showed you Ollama. Llama C++, or you use any other engine, depending also on your hardware and preferences. On my website, you can also find inference engines, an overview, and a wizard and filters to find the best inference engine for your use case. And here you can also compare different engines to each other. Let's say Ollama, Llama Factory, and Llama C++. And you can see the strengths and trade-offs of each inference engine. And then you use your usual stack for front end and back end. So besides of the inference engine, nothing is really new. Another example is using local AI for building an OCR, intelligent document pipeline. And I already did a video about that you can find on my channel. And it's this one here, best OCR tools for AI agents and RAG. And you can run these models locally as well, and they are oftentimes not that large. Here in this video, I go through the exact process how to set this up. I use Docklin, for example, which runs on very cheap hardware. And it's able to extract all kinds of text from documents, even handwritten notes, and also respects the order left to right and so on. Really cool for invoicing, contracts, and agreements, other types of documents. Another example is building your own CRM system with a contact import feature where a local AI model processes all of your new contact information and matches that to the fields in the CRM and then fills in the missing details by searching specific APIs and the web and enriches the record. Especially when it comes to customer data, it's probably the last thing that you want third party to read and process. I built a very simple CRM for myself, and I can just show you how this could look like. Here I would paste in all the contact data that I have. But right now for this example, let's say I want to create an entry for Mark Zuckerberg.
And I was human. I am human still.
And for Lionel Messi, click on extracting with enrichment enabled. Now it's creating 2 rows correctly. And here this information, I didn't provide this yet, but let's click on import and enrich, and it should now fill in the remaining fields depending on what it finds on the web. Mark Zuckerberg is enriched with title, LinkedIn URL, website, location, bio, and company. It didn't find the email and phone of Mark Zuckerberg, sadly. Now let's look at Messi. We also don't have email and phone yet. I think we need Mythos preview for that. Everything else is also filled. And that's just one idea how you can add a cheap local focused AI model to a CRM. Another idea is to augment an ERP system with AI models and features. And one idea is to allow voice and text commands to find items in the CRM and also to create new orders or to set the status of specific orders and to really manage the entire system just with prompts. This is a prototype that I one-shotted with Grok. You see we have a dashboard here with different metrics, and this is for an industrial manufacturer. And now we can prompt it here. Let's say we want that it creates a sales order for Orion Dynamics for 25 servo brackets. And now it's interpreting the command, and it says product server brackets not found. Let's look at our inventory, what we actually have here. So it can make mistakes. Yeah, that's still the case with AI because it's probabilistic in the end. And we still use this very tiny model here. Let's try something else. Create a sales order for pneumatic clamp module for the client Volterra Labs. Now it created the order for Volterra Labs. We have it here, and we see here pneumatic clamp modules. I didn't specify the quantities, but anyways, this is like how this can look like. We can also ask questions about our data, like how many open orders do we have, and then it should give us the number opening orders, and we have 14 orders in the pipeline. Then I can also run voice commands. I could integrate this into the app just by having a microphone button here, but I can also use just my speech to text model that I already run here via Handy on my Mac. Search the inventory for hydraulic, and now it's heading over to the inventory, and it's searching for hydraulic and gives me the results here. You can do a lot of different things with it, basically edit everything you want. You can also set the status here of these orders to complete or something else. Another example is to build your own meeting recorder, and you saw that I already use a speech to text model, and this runs also on most consumer devices. And this way you can transcribe and summarize everything locally. I also built a mobile app for speech to text transcription, which is completely private and free. And you can find this here in the App Stores and Google Play Store. It's called Echoes. I built this for a client, and it's pretty cool. We are working on really cool features, so I can highly recommend you checking this out. As you can see, privacy can beat raw intelligence for a lot of different real-world use cases, and the power really of these small models for running focused tasks, and also the speed is pretty impressive, which is comparable to cloud APIs, and you don't even need to be connected to the internet. If you want to see how I build AI agents with pure Python, then check out this video here next.